Welcome everybody. Thanks for joining us for this web seminar, AV Systems, Cabling and Connectivity Requirements for Reliable AV. The seminar is being sponsored and being presented by Panduit Corporation. Today's presenters, Amy Hacker, Product Manager for AV Systems, and Steve Kwasoborski, Product Manager for Copper Cable with Panduit. Their presentation will cover AV technologies like HD-base-T, AV over IP, maybe some other applications that you've heard of, maybe know a little bit about or could learn a lot about today. It also will discuss the cabling infrastructure that's necessary to support these technologies and these applications. As you watch today's presentation, you could submit questions using the question button that's on your screen. As time permits, we'll have Q&A with Amy and Steve to conclude the seminar. For those of you who hold a credential from BICSI, a professional credential from BICSI, please know that you can earn a continuing education credit by attending today's seminar in its entirety. You do need to stay with us right until the end to get that credit. And once the presentation is through and before we get into Q&A, I'll walk through the details of how you can get that credit. It's through an attendance certificate that we'll send your way. But I'll give you all the detail after the real important information in today's presentation. At this point, though, it gives me pleasure to turn it over to Amy Hacker of Panduit, who will begin today's presentation. Amy, whenever you're ready.
Thank you, Patrick, and thank you everybody for joining today. We're really excited to run through different AV technology options as well as different cabling infrastructure options. So AV has made the transition from being analog to being run over twisted pair cable. Now we see new things on the market like AV over IP, and now it's just become another device on the network. The AV and datacom worlds, or the AV and IT worlds, have officially converged. It's really exciting, and it means a lot of new things for AV. So I'd like to start with some AV fun facts. It's really interesting when you start to look at conference rooms. You actually only need 720p video resolution to make analytical decisions. So a lot of people ask me, where's the #1 place I can save money in an AV application? Well, you can probably save a little bit of money if you don't buy a 4K monitor, because honestly, you're never going to need 4K to see either a PowerPoint or an Excel sheet. AV is huge in education, and we see a huge influx of video conferencing systems on the market. A lot of these video conferencing systems are now incorporating lecture capture functionality, so you can easily record that lecture and have it almost instantly published online. And it's probably no surprise that digital signage, people are attracted to bright, shiny objects over static posters. I always think it's really fun at InfoComm every year to walk around to the different LCD manufacturers and just watch how many people are just standing there staring at the TV for hours. And one really fun fact is the 2020 Tokyo Olympics is going to be broadcasted in 8K video. It'll be the first world event to do this. And so it's going to be really fun to watch all the AV manufacturers scramble to come up with 8K products to be able to support this broadcast transmission. So that'll really be fun to watch in years to come. We probably see a lot of AV manufacturers start to debut 8K products this year at InfoComm and next year. So I mentioned a little bit about AV installations, how it's converging with network installations, and it's often being installed by the same people. We're still seeing HD-base-T being the main AV technology to be installed in small and medium-sized conference rooms, and that's just because of the price point. HD-base-T is a little more budget-friendly right now than AV over IP, but a lot of new installations are leaning toward AV over IP. We've actually heard rumors that AV over IP installations are actually going to outnumber HD-base-T installations for the first time in 2018. And then in the future, there's going to be no separation. AV and datacom are completely converged. Any technologies moving forward, like SDVoE or any AV over IP systems or anything that's on the horizon, those are likely all going to be run over your standard network. So HDMI, when you take a native HDMI cable, it can reliably only go about 15 feet, depending on your quality of your patch cord. Whenever you're looking at purchasing a standard HDMI patch cord, make sure you check the bag or the box for a certified premium HDMI 2.0 sticker. This is going to be really important because you want your customer to get the full investment of their AV system. You want them to be able to transmit that 4K video. And oftentimes with a lot of patch cords on the market right now, if they're not certified premium 2.0, they often aren't going to pass that 4K video signal. And you're going to run into a lot of problems when you start looking at HD-based T systems. It's actually going to affect some of your handshake and EDIT or extended display information data by using a low quality patch cord. So some options, if you don't want to use an HDMI patch cord, is you can run HDMI over a twisted pair cable when you start to hit those distance limitations. That's just going to be a simple box. It's really cost effective. HDMI input, RJ45 output, run it over Cat5e. It'll work just great. Another option is a copper fiber hybrid cable. These are sometimes called fiber ribbon cables. They can be called active optical cables. There's quite a few different names for them on the market, but all it is a copper fiber twisted cable. And the fiber is actually transmitting that HDMI signal, and the copper is powering the transmission of that signal. People that are used to working with fiber absolutely love these cables. A lot of installers that don't necessarily work with fiber every day could learn to hate them. People either love these or they hate these because the fiber in them can break pretty easily, and you can run into a couple problems too when you go to use an HDMI coupler module if it's not going to pass that signal. So the active optical cables or copper fiber hybrid cables, they're a great option if you're used to working with that fiber. So the next thing we'll touch on is HD-based T. HD-based T has been out there since late 2009. You get 5 things over one category cable. And like I said, it's still the #1 install choice for any small conference room, K-12 classroom, and even a lot of boardrooms or lecture halls or big auditoriums are using HD-based T as well. HD-based T 2.0 brought us the USB functionality. The original 1.0 models didn't have that. So for the 5 things of HD-based T, they said audio was 1, video was 1, Ethernet control and power. Now they want to keep the 5-play slogan, so they called it audio, video, USB, Ethernet control and power. The USB is really great for those control systems, and it's going to work with a lot of the different manufacturers' control systems. There's also different HD-based T chipsets out there. They're all manufactured by Valens out of Israel, and they have different specifications. So now there's new HD-based T chips where you can run them over fiber. You're not going to get that power capability, but you're going to be able to go a long distance. There's limited distance HD-based T chips for those budget-friendly solutions, and there's extended distance HD-based T chips. They can actually run up to 150 meters over a single Cat5e cable now. A lot of people ask, what is the difference between a high-end HD-based T device or a low-end HD-based T device? Or why can I go on Amazon and find something called HD-based T under $50, but then you see the high-end manufacturers charging upwards of $1,000? And the difference is actually the chips that people put on the PC board in front of the HD-based T chip. So what you're going to see with those high-end manufacturers is they're going to put an amplifier chip, a repeater chip, and a couple other additional chips in front of that Valens chip. What that does is that actually limits your interoperability. So now you're going to be able to use more laptop models, more TV monitors, less firmware updates, and overall better reliability for your system. That's what that gets you. So here's a way that the HD-based T Alliance recommends a setup. You're going to have either a Blu-ray player, this could be a PlayStation, this could be a laptop more commonly in a conference room. You can run it through a matrix switch. You can run up to 100 meters and have that control functionality. You don't need to use the matrix switch. Often HD-based T is just run point to point, like in a conference room in an isolated system. A lot of the projectors on the market today, Avixa actually says over 95% of the projectors on the market today have an HD-based T input. This is really great because what it means is you don't need a receiver. You can run a transmitter through or not through a matrix switch and straight into the back of that projector. One thing when you're using the HD-based T functionality in a projector that you need to remember is that you're going to need to apply power to your transmitter side of your HD-based T system. The projector will not be able to supply power to your transmitter, or you're not going to want it to because it can actually burn out that transmitter. The next topic I want to touch on is AV over IP. AV over IP is great because now you can use that standard network IP switch. Most manufacturers recommend that you use a PoE-enabled switch just because a lot of the AV over IP systems utilize PoE. There's often going to be some sort of video compression, whether it's H.624, JPEG 2000, something like that, in order to compress that video and send it over your network and over that 1 gig switch. The biggest advantage with AV over IP is that moves, adds, and changes are incredibly easy. It's so easy to add an extra input after you already have an installation set up. The control software on the market today is fantastic. You can have something set up in under 10 minutes. And it's just going to be easy. Whenever you need to add those inputs and outputs, you're not going to have to reconfigure your HD-based T matrix switch like you had to do in the past. AV over IP is still a little bit more expensive than those HD-based T systems, but luckily the price is dropping really quickly as more manufacturers come out with systems and the market becomes more commoditized. So that's really great for the end user, and we're going to just see more and more of it moving forward. There's some new AV over IP standards. Software-defined video over Ethernet is the first. And the biggest advantage that you get with software-defined video over Ethernet, or SDVoE, is that it's a 10 gig technology, and that is going to get you 0 latency. So you're going to have to use Cat6a cable or fiber with a 10 gig switch, so there's a lot of cost associated there. But you're really not going to find another video technology that gets you that 0 latency. Right now, it's pretty pricey, so it's probably saved for those bigger budgets such as operating rooms, control rooms, and government applications. But like everything else, the price is dropping. We'll likely see it come into more corporate office environments. Another technology is IP-based T. It's a technology by Valens, who makes the HD-based T chipset. They didn't want to be left out of the race in the IP transition, so they came up with their own AV over IP system. We don't see this quite as adopted by manufacturers as SDVoE, but it's likely going to be a force to be reckoned with in the future. And then we get to digital signage. So there's multiple ways you can do digital signage. A really common one is just stick a media player behind every digital sign. You can stick an iPad behind there. It's going to be super easy, not a lot of interface. But most of the cost that comes with this is actually the content creation. So we see a lot of customers, and they spend all this money installing this beautiful digital signage solution, but then they don't have anybody to keep up the content. So now all of their digital signs are blank, defeating the whole purpose. So really, I recommend make sure you have the content, make sure you have content management software, and are easily able to upload it to all your digital signs. Another way people did digital signage was HD-based T, because it has that daisy chainable functionality, so you could daisy chain up to 5 receivers behind multiple signs. This is actually getting replaced pretty quickly by AV over IP. AV over IP, in my personal opinion, is going to be the way of the future for digital signage because it's just so easy. It's so easy to add another sign, add 10 more signs, add 20 more signs. The possibilities are pretty much endless. And lastly, I want to touch on wireless AV. So wireless AV, the technology is getting better every day. So it's becoming more reliable, the costs are coming down, it's easy to deploy, it's great for those retrofit applications where you don't have access to core drilling or you just want a simple plug-and-play solution. Unfortunately, with wireless AV, some of the downsides are compatibility issues, frequent firmware updates. It can provide additional traffic on your network, and with some instances and some devices, there's actually security concerns as well. You have a guest presenter coming into a corporate enterprise, and now they have access to their whole network by just accessing their AV wireless system in one conference room. So not the case with all manufacturers, but a couple of the wireless solutions out there do have that security concern, so just be aware. And one interesting thing with wireless is we actually would expect it to grow faster than it is. But what's happening is that even when people install a wireless AV solution, they're also installing a structured cabling solution. So even when they have that wireless solution, they're often installing HD-based T or some sort of other video transmission feed for backup and reliability. for if that wireless system goes out. So actually, we have yet to run across an application that does not have both the wireless and some sort of structured system. Most people really like installing both. And with that, I'm going to turn it over to Steve to talk about all of the copper cable and connectivity that you need to support all of these different AV applications.
Thank you, Amy. My name is Steve Kwazaborski. I'm a product manager here at Panduit for copper cable. So I'm usually on the networking side of the business, but as Amy had mentioned earlier, network and AV systems are now converging. So the way I'm adding to this webinar, I've been asked to provide my expertise to this regarding networking cable as it's become more relevant to the AV space. So Amy touched on the HD base T 5-play, which is common also to AV over IP. So in the next section of the presentation, I'm going to focus on the audio-visual and the Ethernet part of that 5-play. So that, just to recap what that 5-play is, it's audio-video, Ethernet, power, control, and USB all over one cable. So utilizing network cable, AV signals are able to go further than they did previously with just HDMI cables. So the first decision point you might come across is the cable choice and what category cable you might use. So in order to support HD base T and AV over IP transmission, a category 6 cable is perfectly acceptable for a bundled cable. When you get up into higher or you start to bundle cables, you need to start mitigating the effects of alien crosstalk. And this is required for higher frequencies that are common to Category 6A. Category 6A cables actually mitigate alien crosstalk by design. It cannot be compensated for by equipment. And just to give a step back and give a definition of what alien crosstalk is, it's an unwanted signal coupling onto a twisted pair from another cable's twisted pair. So it's called alien because that disturbance is coming from outside the cable's jacket. And that's why it can't be compensated by equipment. So our recommendation is to install Category 6A cable when you're using a bundled cable. So Panduit has performed lots of testing on different cables in AV applications, and this is one example of that. This is a representation of a 6-around-1 configuration for 2 cables, one cable bundle with Category 6A on the left, and Category 6 on the right. So what we noticed was with Category 6A, there were no interruptions. With Category 6, there were some effects of alien crosstalk, and we had intermittent signal interruptions on that display, on the displays on the right. So our recommendation is to install Category 6A when bundling cables together. And we'll be showing this mock-up at InfoComm next week, and make sure you stop by and say hi to Amy. Another decision point you might come across is, should it be a shielded or unshielded cable? Well, the shielded cable pros are that shielded cables provide the best performance for EMI and alien crosstalk. Another one that isn't actually related to the performance, but it's more of a market-driven demand, is that equipment manufacturers may require shielded cables for their warranty. Now, the cons against shielded cable is there's increased labor costs for over UTP or unshielded solutions, and that includes material as well. So when you're installing shielded solutions, AV applications may make the grounding difficult, so there may not be a ground bar near the projector, for example. And if it's not done correctly, the performance is worse than if you would have just installed a UTP or unshielded solution. So Panduit's recommendation is, in most cases, an uncompromised Category 6A UTP is the best option. So there's 2 points that I want to make there. First of all, if the equipment manufacturer is going to require shielded cables for warranty, we're not advising you to go against that. We think that the Category 6A UTP cable will be just fine. And then the uncompromised I have underlined there, which we're going to go into in further detail in the upcoming slides. So there are some common sources of low-level EMI in AV environments, and usually those can be combated or UTP solutions are fine for these, but you don't want to have an uncompromised UTP cable. Some common sources of electromagnetic interference, or EMI, are light ballasts for fluorescent lighting fixtures, cordless phones, also motors in the workplace. So pencil sharpeners, paper shredders, or cordless drills, those all generate EMI. And then walkie-talkies will also generate EMI. So any one of these things could generate EMI and cause a disruption in your AV signal. So there are common sources. And what we found is that on some designs that are out there in the market that use a ungrounded solid foil barrier tape, so that's a barrier tape that was designed to combat alien crosstalk, will actually act as an antenna for EMI. So it gives great alien crosstalk performance, but it degrades the EMI performance. So that will act as an antenna for EMI and then could be coupled onto the pairs and disrupt your signal, giving outages at your display. And those signal interruptions are unpredictable and often difficult to diagnose because no one knows when someone's on the phone or if the lights are on or lights are off. It's totally unpredictable. So what we would recommend is a segmented foil UTP cable. So foil barrier tapes are exceptionally effective for alien crosstalk, and that's true of if the barrier tape is cut or uncut. What the segmented foil tapes do is they don't compromise your UTP EMI immunity. They don't act like that antenna. So in the first picture, or the first display there, picture of cable we have there, that's a continuous barrier tape. That's susceptible to EMI with the antenna effect. There's also another design where we break the segments, or break that tape into segments, and that's the EMI is much improved. Panduit has done a lot of research in this area, and we've found that we get the best UTP EMI immunity if we break those segments into a varying segment length. So that's the best UTP EMI immunity you can get. As far as other additional benefits of these segmented foil tapes, you're getting a smaller cable diameter. And that's achieved because you're using that tape to combat alien crosstalk rather than making the jackets larger. So that'll give you better fill rates and flexibility. And also those foil tapes dissipate heat better to the outside environment for PoE applications. So speaking of that, we're going to look at another aspect of that HD-Base-T play, which is the power component. So the first power over data cable standard that we're going to look at is power over Ethernet, or PoE. So this is IEEE standards based, and this is up to 100 watts, and that's for Type 4 PoE++, and that's at the source. The second one is power over HD-Base-T, also known as PoH. This is also standards based, but it is HD-Base-T standards based. It supplies voltage to meet the application requirement. So where PoE provides like a worst case scenario, with power over HD-Base-T, it's a little bit smarter and only provides the power required, the power that's required. It also supplies about 100 watts at the source. And then there's power over cable, or POC. That's non-standardized and proprietary. It is typically most like HD-Base-T, where it supplies the power only needed to meet the application requirement, and it's up to about 100 watts. So the main thing you need to keep in mind with PoE is the temperature rise in the bundle. So I have a cross-section shown here of a large cable bundle, and what we're trying to do is limit the amount of heat rise in the center of that bundle where that red dot is. So TIA has put out a technical service bulletin which put a cap on that temperature rise at 15 degrees C. And what we're saying there is that if your cable temperature increases more than 15 degrees C, you'll end up seeing signal degradation. And if exposed to that temperature rise for a long period of time, it could cause physical damage to the cable. So we don't want the temperature to rise more than 15 degrees C. So in this next slide, at 15 degrees C on the y-axis, I have that red line shown there. And what this graph is showing is the temperature rise versus the bundle size for various types of cable. And this is all model data from the TIA, the technical bulletin. So the first one we want to look at is the model for Cat 5e, and you'll notice that it crosses that 15-degree threshold at about 60 about a bundle of 60 cables. With a Category 6A cable, that orange line, it goes up to about 100 before it were to cross that 15-degree threshold. Now, Panduit has done a bunch of testing on this as well, and we found that cables with foil tapes, like our matrix cable, and there are other cables on the market just like it, that it dissipates heat faster to your environment and will actually be able to put a larger cable bundle together before it crosses that 15-degree threshold. It's actually unlimited from our LP rating. So the key here is that Category 6A cables generally perform better than 5E and 6, and Category 6A cables with foils do not get as hot. And an analogy I like to give there is that the foils are made out of aluminum, and so are radiators, so it dissipates the heat faster to the environment, where traditional UTP cables without the foils have air pockets to mitigate the effects of alien crosstalk, and that acts just like a thermos and keeps the heat inside the cable. Another effect of the heat is going to be on the channel length. So in this table, we show a temperature rise from 20 degrees C up to 60 degrees C, and what the length is, or what the impact is on the channel length. Because more heat will decrease the channel length by increasing like insertion loss or your resistance. So in the middle column, we're showing an unscreened, so that means like an unshielded or a UTP cable. And you can see the distance goes from 90 meters down to 75. And on the right side of the table, we show a screened or a shielded cable. And also, foiled cable will also act like this. A UTP with utilizing a foil will have the same characteristics as this does. And you'll notice it goes from 90 to 83. So it loses about only half as much as an unshielded cable. So what that means is Category 6A cables with foils go further. So POE is not inherently dangerous, but up until the 2017 National Electric Code, there were no limitations on it. So the NFPA put some new regulations in the 2017 code. So it doesn't apply to anything that operates at 60 watts or less. We think that's going to be the majority of the installations. And what the code means is that POE applications are going to be subject to inspection. So they're going to look at how much power you're running over your cables and what the bundle sizes can be. So UL has come up with a way to streamline that inspection or basically bypass it. If you have a UL listing of an LP or limited power cable, you're not subject to that inspection. You just show that you have an LP listed cable. So LP listed cables are not required to run POE. It's just going to streamline your inspection process. If you don't have an LP listing, you're just going to have to refer to the ampacity table in the 2017 National Electric Code. There's a lot of uncertainty on how these inspections are going to work. It's likely going to vary by state and the local interpretations. So we think may occur by application type. This one might be something you guys already know, but just figure I'd review this with you as well, is the cable flame rating. So in air handling spaces, a plenum cable or CMP, the flame rating is required. This is the most stringent type of flame rating. Between floors, so like perhaps in an elevator shaft, you'll be able to use a riser cable. Also where we're located and where you're putting cable into conduit, a riser cable would also be acceptable. And there's also a different type of cable called CM, or Communications Multipurpose, and that's where there are no fire code restrictions. So that is typically what we see for patch cords. But these cable flame ratings, if you're going to put it any type of cable in a plenum space, it must be a plenum. So it applies to horizontal and patch cables. Another thing that you have to think about is the channel configuration. So AV over IP must conform to network channel configuration. So in the picture here, I have a couple of different configurations: a 2-connector channel and a 4-connector channel. So TIA allows for a 100-meter maximum, so that is your limit. And you must derate for smaller wire gauges. There are calculators on the web. Panduit actually has a really good app where you can put together different cables and patch cords with different wire gauges and determine how long of a channel you'll be able to get out of it. And next is how you're going to configure your channel. So there are some new field terminable plugs on the market that make it's a new option where it eliminates the need for a patch cord and a surface mount box. That was a more traditional type of installation where you would terminate your horizontal cable to a surface mount box, where then it would plug into, or where a patch cord would then plug in on one end to the surface mount box and then to your equipment. This can go straight from the horizontal cable right into the equipment using this field term plug. So the new products are really easy to install. They terminate just like a jack. There's a new testing procedure that's out there, so your fluke meters will work with this new procedure. And there's less potential failure points. Less components means less failure points. And overall, it's going to be less expensive from a material and labor standpoint. If needed, you could still go with the patch cord with a surface mount box, as that's the legacy design. There's familiarity with that old design. And you're able to extend lengths with a patch cord. Also, stranded cables are a little bit more flexible, so you'll be able to get into tighter spaces in some instances. So that wraps up the sort of the networking portion of my presentation, and I'm going to throw it back to Amy to wrap this all up.
Thanks, Steve. And we know that each AV application is a little bit unique. Some systems are point-to-point in a conference room. Some systems are networked. But by really considering your network and your infrastructure, you're going to be able to get the performance required by the end user. So if you pay the money for that great 4K or 8K video system, you want your end user to be able to utilize that. And the only way they're going to be able to do that is if the infrastructure can support it. So for right now, we say, Cat6 UTP cable is great for those point-to-point applications, but the second you start to bundle cables, or the second you start to utilize POH or PoE, you really need to turn to that Cat6A cable. And that becomes even more relevant with AV over IP. AV over IP now has to conform to all those IEEE specs, TIA specs, and it's often going to be bundled with both other AV cables and data cables and other different types of cables. So you really need to be aware of the heat rise and the different power transmission sources. One other thing I want to touch on is that AV over IP is a two-way transmission, whereas HD-based T is often a one-way transmission. And what that means is often HD-based T applications sometimes got low skew cable associated with them. That low skew cable can be great because you're not going to have as many pixel drops. But when you look at AV over IP, it becomes a two-way transmission. Your Category 6A cable is going to become incredibly important. Most low skew cable actually doesn't even test to Cat 5e standards. So your Cat 6A system, you're using it in other places around your enterprise. Go ahead and use it for those AV systems as well. You can definitely go with the UTP Cat 6A option, save a little bit of money over that shielded option, and get all the performance that you're going to need out of your infrastructure. And to wrap it up, we've seen AV go on this great journey from analog to digital and digital to IP. We've seen all these different AV technologies out there. It's incredibly fun to look at where different applications might use different technologies. But in the future, all of it's going to go in AV over IP, whether that's SDVoE, IP-based T, or a proprietary system. One of those is going to win out, and we're going to see a lot of that. And to support those, just make sure that your infrastructure is abiding by those codes, meeting regulations, and can support that AV system that is so incredibly important to the end user. And thanks so much. With that, I'm going to throw it back to Patrick.
Amy, thank you very much, and thanks to Steve as well for the information provided here. We'll be ready to get into Q&A in a moment, but before we do, I just want to extend a message to those of you who hold a BICSI professional credential. As I indicated earlier, you can earn 1 continuing education credit toward the renewal of that credential by hanging on with us now until we sign off after Q&A. What will happen then is you'll see a notification on your screen that we are done, you've completed it successfully, and shortly after that, an email will come from us to you. If you could give us about an hour's time or so after the conclusion of today's event, take a look in your inbox. You should see an email there from us. That email will include a URL, a link to your attendance certificate. That attendance certificate is what BICSI will accept for your attendance today and for your continuing education credit. So that's the process of getting a continuing education credit from BICSI for your attendance today. Once we're done, you'll see a thank you message. That'll be followed by an email. That email will bring you to your attendance certificate. If something doesn't go as planned there, if somehow you don't find your way all the way to an attendance certificate, please email us at the address that's on the screen in front of you, webcastmaterial@penwell.com. That's where we can receive your message, and we will verify your attendance and issue that certificate to you. So if you don't hear from us, if you don't receive that certificate from us, that link to a certificate from us, please do email us there and we'll get the certificate to you. So thanks again for joining us. I would like to get into Q&A now. If we have Amy again, I'd like to at least start with some questions for Amy, and we'll see where we go from there. Do we have you, Amy?
Yep, I'm here. Thank you.
Thanks, Amy. Early in your presentation, I believe you mentioned a transmission distance for an HDMI cord, and I believe a question came in from the audience either asking for a repeat or a little more detail or a clarification on that. It asks how far is a transmission with an HDMI patch cord. If I remember correctly, Amy, you said it may vary up to a certain length depending on the quality of the cord itself, but I certainly won't try to answer for you.
Yeah, absolutely. So it will absolutely vary depending on the design of the cord. Typically, if you're looking to do 4K video, 444 video resolutions, it can only go about 12 to 15 feet. If you're only aiming to achieve 1080p video signal, sometimes you can get up to that 20, 25 feet on a good day. It definitely can't really go longer than that. We found that in our lab. And oftentimes, a lot of the patch cords can't even transmit 4K video that are on the market today. So that's why I said make sure you double check for that certified premium sticker on your bag or your box.
Thank you, Amy. The next question is similar. I just put in front of the audience, or at least I tried to, hope that I did, a slide that you presented in which you discuss a copper fiber hybrid cable. And a question specifically came in about that while you were presenting about that, and asks, is there an under-carpet version of this hybrid copper fiber hybrid cable that you discussed?
Yes, so with any under-carpet system, we would definitely recommend some sort of pathway or conduit. The fiber in these is incredibly fragile, so you would want to make sure you have that conduit. And these cables also come in plenum versions and riser versions as well. So there's multiple different options, and you can get it under your carpet if you need to through conduit or some sort of above-floor raceway system.
Thank you, Amy. One more for you, at least one more for the time being, and then we'll see where we are with questions. The question considers or concerns economics, cost competitiveness, talking about HD-base-T and AV over IP. So I'll simply read the question as it came in. Without the need for an HD-base-T matrix switcher, doesn't that make the price of AV over IP much more competitive? In other words, if you're talking about AV IP, there's not the need for an HD-base-T matrix switcher, and so does that sort of put them on a competitive level with each other, or sort of how does that factor in when one is considering the economics?
Yeah, those HD-base-T matrix switchers can get pretty pricey pretty quickly. So in some of those instances, AV over IP definitely does become the more cost-effective solution. So HD-base-T is still being run a little bit more point-to-point than it is through that matrix switcher. People have gone away from using the matrix switcher. But if you're using it, AV over IP is definitely going to be less. Those IP switches, even the PoE-enabled IP switches, are a lot less in cost than the traditional HD-base-T matrix switch.
Thank you, Amy. Thanks very much for that. And I'm taking a look, and I know that there are maybe a couple of questions that came across the desk today that may require some individual follow-up. So if you've submitted a question and we haven't addressed it here, please know that work is being done on it, and we're likely to reach out to you at some point with some detailed information on the question that you submitted. But thank you very much, Amy, for the answers to those questions, and to everybody who submitted today. And it looks like that is just about going to do it for us. So I will. Oh, you know what? One just came across the desk as I was about to sign off. So let's see. My apologies. Nope, that was my mistake. We are indeed done. With questions and about to sign off. I swear I'm not just trying to keep you here an extra minute for your Bixby credit. You're going to get it as soon as we sign off. So I'll go through the official wrap-up. On behalf of Cabling Installation and Maintenance and Penwell Corporation, I extend thanks to today's speakers, Amy Hacker and Steve Kwazaborski, as well as our sponsoring organization Panduit for this presentation. Thanks again, of course, to the members of our audience who joined us, who submitted questions, and again, to the handful of you who may have sent questions our way that require a little bit of follow-up. Please know that follow-up is going to be done, and you may be reached with some detail there. So thank you once again for joining us. We certainly appreciate your attendance, and we wish you all a good day. Thank you again.